structural worksuite, the complete workflow for the concrete structures. With me, my colleague Madan Elumalai. He will be presenting. He is the Senior Technical Manager, Engineering Simulation for Bentley Systems. Let me talk about today's agenda. We'll talk about Virtuosity and the practitioner licenses. We'll also discuss about the structural worksuite and introductions. Then the concrete building analysis, design, and detailing for Singapore and Malaysia Annex and Eurocode, and BIM Interoperability, and we'll having the questions and answer sessions. So let's talk about the practitioner licenses and Virtuosities. Virtuosity is the new online platform of the Bentley Systems that aims to provide you an easy way to purchase Bentley products through the practitioner license. It offers completely priced, industry-leading products with expert training and makes it quickly and easily available to purchase online. Virtuosity provides Virtuoso subscription and keys with each purchase that can be used to help pay for expert services and training that you need to take your project to the next level. The number of keys received with each subscription varies based on the software you purchase. The keys provide you add-on value to Virtuoso subscribers with exclusive rights to the tailor-made training materials built specifically to help you work more efficiently. Now with the keys, you can choose our wide range of expert services. This is trainings, virtual classroom trainings, on-demand sessions, standard and customized training, consulting and mentoring services to build the support program needed for your engineers and designers. Our expert services will help improve your design, analysis, and modeling skill to help increase productivity and reduce time away from the project work. Now, in order to get started, basically, you need to log into our virtuosity.com, the website. It's pretty simple, and you can check it out today itself, and you can choose the particular product that you need, and then select it and go to the add to cart, and you can complete the purchase from our secured online shopping cart using a preferred payment method. And upon processing, you will receive an email to register and access your practitioner license and training. Now, you can see that this Virtuoso subscription is basically open to all. Anyone actually can subscribe as an individual, as a company, or existing clients or new clients. Basically, they find it's pretty easy to get this software. You can get our expert services, technical support 24/7 basis, and you can get any kind of product updates and upgrades, whatever released within 12 months. It's pretty simple process. There is no paperwork required. No excess uses, anything is chargeable in that way. It's very much transparent. You can see the pricing, and so it's open to all. And moreover, upon you order, within 24 hours, you'd be able to proceed for the installations. And after that, around 12 hours, you can also book our expert services. Yeah. So let's proceed with our presentations. With Mr. Madan Elumalai. Yeah. So Madan, are you ready for the presentations?
Yeah.
Okay.
Can you make me as a presenter?
Okay. Sure.
Let me do it myself. Yeah.
Let me change. Okay.
Okay. Okay, can you see my screen?
Yeah, sure.
With the PowerPoint?
Yeah.
Okay, greetings engineers. Welcome to this webinar on structural worksheet, complete workflow for concrete structures. Before I start my presentation, I would like to engage you in some polls. So please help me in answering 2 polls. Okay. So I'm opening the poll. So what is the structural analysis software that you currently use for concrete building analysis and design? I'll give you 10 seconds to answer this. Please help us understand you. Note the word concrete buildings. Okay. So I see most of you answered StatPro, and some of you ETAPS, and some others. I see few of you even answered for RAM structural system also. Okay, good. But majority of you, 75% answered StatPro. Only 4% answered RAM structural system. Okay, so thank you for participating in this poll. Let's move on to the next poll. Sorry, the next poll supposed to be after the webinar. So I will now close the polls and start my presentation. Okay. Hope you are all able to see my PowerPoint on the screen. Okay, so first let's introduce Structural Worksheet. For those who are not familiar with Structural Worksheet, it's a special bundle license of around 8 products from STAAD and RAM brands. It includes the StatPro Advanced license. Some of you may already familiar with StatPro. It's a general purpose structural analysis design and detailing software. Nowadays I even started adding the detailing to explain this software, because it has now concrete and steel detailing features as part of the software. Okay, and number 2 is STAAD Foundation Advanced for foundation analysis, design and detailing. This is fully as a standalone software and also integrated with StatPro. So you can use it in both the modes. And third one is RCDC FE. This is not RCDC. RCDC is part of StatPro Advanced now. And even the basic features of RCDC are even available in the StatPro basic license itself. RCDC FE is a different software from RCDC. It is for slab and mat foundation design and detailing for StatPro users. Okay, the model has to be the mat foundation model or slab model has to be analyzed first in StatPro, and then you read the results in RCDC FE to finish the design and detailing. Okay, and RAM structural system is for building structural analysis and design. So it's a special purpose program for buildings. Okay, steel, concrete, composite, post tension, anything you call, everything can be done in RAM structural system. RAM concept is a specialized program for slab and mat foundation design. It is well known for its post tension capabilities, but many users have started using it for normal reinforced concrete slabs and mat foundation also, because it's very user friendly. And this program also has a 2-way interoperability with RAM structural system and 1-way interoperability with StatPro. And the 6th program is RAM connection, which is a steel connection design and detailing software. It can work as a standalone program, but it is having interoperability with the StatPro as well as RAM structural system. So when you finish the steel buildings, either in RAM structural system or RAM StatPro, you can call RAM connection directly into those programs to design the connections. This way, we don't need to feed in the connection forces. The program will take from the structural analysis program, STAAD or RAM, and then proceed with the connection design, saving a lot of time for the structural engineers. Number 7 is RAM elements. It's for component design and detailing for everyday use for structural engineers. For example, retaining wall design, single column, single beam design, steel and concrete. Okay, so like a fill in the blank spreadsheet kind of software, RAM elements. Okay, MicroStrand Advanced is the 8th product. It's a general purpose structural analysis and design software widely used in the Australian and New Zealand region. So these 8 products combined together, we now have a special bundle license called Structural Worksheet. So when these programs are bought individually, it will be expensive. So by buying this bundle license, it will be much more cost effective. So for today's webinar, I'll be using only 2.5 products. Okay, mainly the 4th and 5th product, RAM structural system and RAM concept, for because the project which I'm going to show you is a concrete building. a 10-story concrete building, and part of StatPro. Only the RCDC portion of StatPro Advanced, I'll be using it in my presentation. So that's why I say 2.5 products. Okay. In next month, we'll be covering steel buildings. At that time, we'll be including RAM connection, the 6th product also. So for my presentation for another 45 minutes, the agenda is like this. I'll be suggesting the workflow for the concrete building modeling, analysis, design, and detailing. And then I show the modeling of the concrete building, the 10-story building, 3 different methods, 3 different buildings, varying from high-rise building, first method, and varying to low-rise building, the second method, and to a medium-rise building, the third method. Okay, and using completely 3 different workflows. And then third step is how do I apply the lateral loading, such as wind and seismic, which usually takes a long time in general purpose structural analysis software like StatPro. But with RAM structural system, it is much more easier because it's a specialized program for buildings. And then the 4th step would be gravity analysis for preparing the model for concrete design. And then the 5th step is actually performing the concrete design, detailing, and estimation. Okay, that's where I use RCDC. And 6th one is foundation design. If it's a mat foundation, I would use RAM concept. If it is isolated footing and pile cap, I would use RCDC. Okay. And finally, 7th last step is the BIM interoperability with our Bentley Open Building Designer, a similar workflow for Autodesk Revit also. So first, let's proceed with our suggested workflow. So if your office have a BIM team who uses a BIM software like Open Building Designer, which is from Bentley, or Autodesk Revit, you can start the modeling from this BIM software. The reason for using the BIM software is several reasons, such as multidiscipline coordination and clash detection between other disciplines and structural disciplines. So that's why many users have a separate BIM team. The other alternative way is to model the model in RAM structural system itself. Okay, and then after you finish the structural analysis and design, after optimizing the member, you can push the model into BIM software. That's why I put in a 2-way arrow. Okay, so the modeling can be starting from RAM or BIM software. Both ways okay. It's up to your skills and up to the workflow that you have in office. If you have multidiscipline teams in your office, it's better to start from the BIM software. But if you have a specialized structural consultant, you can start from RAM structural system. And after you finish the analysis in RAM structural system, you can proceed with the concrete element design like beam, columns, walls, and foundations using RCDC. We call this RCDC as TAD Advanced Concrete Designer. The old name is RCDC. Okay. And then for mat foundation and slabs, long span slabs, post tension slabs, slabs with opening, we can use RAM concept. If it is a simple 1-way or 2-way slabs, we can either use RAM concept or RCDC. Okay, but note the double arrow for RAM concept and note the single arrow for RCDC, because if you use post tension slab, then the updated column forces due to the post tensioning can be imported back in RAM structural system to update the column forces. So that's why this 2-way interoperability between RAM structural system and RAM concept is very important, particularly if you do post tension flows. So more details about the structural workflow, building structures workflow particularly. So use RAM structural system to model, analyze, and design your steel and concrete buildings. Use RAM connection to design the steel connections. Use RCDC to design and detail your concrete elements. Use RAM concept to design and detail the elevated slabs and mat foundations of both reinforced concrete and post-tension concrete. Generally, I prefer to do the modeling in RAM structural system, except when the building is made of flat slab, where modeling in RAM concept is easier. Today, I'll be covering both the workflows. Okay. 2-way interoperability with RAM structural system, RAM concept makes life easier for structural engineers. After finalizing all the members and wall sizes, export the complete model into a Bentley Open Building Designer for documentation and multidiscipline coordination. So when I say documentation, you can produce several drawings like plan drawing, section drawing, elevation drawing, and quantity estimation. And if you have the other discipline model such as architecture, mechanical, electrical, you can reference that file in Open Building Designer and perform clash detections, etc., etc. So today's workflow, I'll be covering almost all the steps except the second step, because the project which I'm going to show you is concrete buildings, which doesn't require RAM connection. Okay, so the RAM connection we'll look at our next webinar next month. So now we'll go on to the modeling of the building. I'll be showing the three methods. First method is importing the CAD grids and tracing over them. And the second method is importing the model from RAM concept. And third method is modeling in RAM structural system itself. And then we'll also see the integrity check in RAM modeler, which is very important to check your geometry, and how to apply the gravity loading, such as dead and live load. Okay, that's what we'll see now. So first 2A, modeling, importing the floor plan DXF grid. So on the screen, you can see Bentley MicroStation, where I have this architectural grids given to me by the architectural team, okay, which has a conceptual layout of the project, okay, showing the walls and grids. The grids are very important, and particularly when the grids are inclined, it is going to take a long time for me to model it in RAM structural system. Whereas if I use this grid import feature in RAM structural system, it is going to be much easier. So here what you see is RAM modeler, RAM structural system, RAM modeler. Here I'm creating some floors, floor layout, okay, and then I'm going to import the DXF file. And just now I showed you the MicroStation DXF file where I noted down the layer name of the grids and grid labels. And here I'm selecting the grid label correctly, which I noted down from MicroStation. And then I imported it in RAM structural system, RAM modeler. And now all I need to do is trace my grids, place the columns, so beams, walls, slabs, etc. Note that this project doesn't have any columns. It's all walls and beams. Okay, and after I place the walls and beams, I place the slab. Just one button click automatically creates a slab with an overhang of 350 mm. And now for creating the openings, all I need to do is just click a button on the opening, and the program will automatically create the opening with a overhang of 150 mm, which I just modified. That's it. We finished the first floor modeling with the help of grids. And some of the grids are inclined, and that's where the complexity is. And now I assign the thickness for the slab. And now let's have a look of the isometric view of the ground floor, which I created, just one floor. Okay. Just shear walls and beams and slabs. Okay, in the middle is a lift core. We have 6 lifts. And now I'm going to show you how do I model the mat foundation for this entire floor. Okay, I'm giving an edge offset of 1.5 meter, and I'm going to click on all the boundaries of my building. Okay. Okay, so just by clicking on the boundaries of the floor and giving an offset of 1.5 meter, I was able to create the mat foundation very easily. Now all I need to do is specify the thickness of the mat. I'm going to give a 2 meter thickness of the mat because the this building, this floor, I'm going to copy to 80 floors to create a 80-story high-rise building. And all the 80-story, I'm going to use the generate feature in the story data in the RAM modeler. So 1 to 80, and specify some prefix and suffix and the style for the floor generation. Okay, so that's it. Hit the add button. 1 to 80. Each floor is 3 meter height. We have finished generating the 80-story high-rise concrete building. That's it. So see here, we have just taken a few minutes. Of course, I didn't show you the placement of the walls and all, which is very easy. So less than 15 minutes, I would say 15 to half an hour, we can easily create this 80-story concrete building. That is method 1, using the floor plan DXF grids from any CAD software. Now let's go to the method 2, a low-rise building with a flat slabs, no beams. Okay, modeling in RAM concept. So on the screen, you see a RAM concept empty screen. I'm choosing the code, and any code you can choose. Here we are just talking about modeling. and then we are importing the DXF file. I'm just using a tutorial metric DXF file, flat plate metric DXF file. And here we got this flow plan from the CAD program. And using some tools here, I'm measuring the column to column distance, and then I notice it's 9-meter column spacing. Definitely, this is going to be challenging, okay, because it's 9-meter column spacing, no beams, flat slabs, okay. And then I trace over on this grids to create my columns, slabs, column drops, opening, wall support, etc. And then I do finish the analysis of this slab either as a reinforced concrete or a post-tension slab, make sure the slab is safe, and then I export this to RAM structure system. Just give a typical floor type, and then export the complete geometry to RAM structure system. And from RAM concept, directly I open RAM structure system. And this is the RAM structure system screen. And I go to RAM modeler. And I select the typical floor, which I have exported from RAM concept. And you see the geometry is already exported. All I need to do is just specify the floor to floor height and then turn this floor into a 4-story or 5-story building. That's it. That's it. Our 5-story low-rise building is now ready within a few minutes. Flat slab concept. And the opening is for the staircase. Okay, so we have seen 2 methods. Now let's move on to the third method of modeling using the grids inside RAM structure system itself. So empty screen of RAM structure system, in RAM modeler, we are creating a floor type called typical, and the typical one, and roof. So 3 floor types I have created, which are empty. Now I need to go to the layout grids, and instead of importing from DXF, this time I'm going to manually create the grids. So I name the grid label as column grids, and here I'm generating the X direction grids as alphabetical grids, okay, with a spacing of column spacing of 6 meter, 7 grids, okay. So 7 into 6 meter equal spacing, and the Y direction is numerical labeling, 5 meter spacing of 5 meter grids, okay. And any extra grids we can create it and add it. For example, I created a grid label of 3.1 at 13 meter coordinate, okay. So in the X direction is 6 meter spacing, in the Y direction it is the 5 meter spacing. And now I'm placing the concrete columns on the grids. And notice that I am placing lateral columns. While you are placing, you can specify the member as a lateral or gravity member. This is one of the unique feature of the program, which we generally don't find in general purpose structural analysis program. A lateral member means it takes lateral load and gravity load. A gravity member means it takes only gravity load. So this way we can achieve, we can have full control on the way we distribute a lateral load, such as seismic load and wind loads. Okay. So now I'm modeling my shear walls, which is again a lateral walls. So all the 4 sides I have 2 walls each, and in the middle I am going to place a lift core. And I also place some gravity beams, which are shown in blue color. Okay. And some lateral beams, which are in red color. And I also shown you the member releases, which you can control in the program. Some are simply supported connections, some are, most of them are rigid connections. And now I'm modeling the floors, the slab for the roof, as well as the other typical floors. And I'm generating the story data for 10-story buildings. That's it. I have the 10-story building created. And I'm now going to model the foundations. For some columns, I'm going to use isolated footings, like the corner ones. And the middle columns have a pile cap, and the lift core in the center has a mat foundation. And I have created the opening on the slab also. And this shows the modeling of the mat foundation for the lift core. The lift core is 6 meter by 3 meter. So we have finished modeling the mat foundation, and now we specify the thickness of the mat. That's it. Our model is now ready. We can now look at the elevation view, and there you can see the shear wall. Let's see how easy it is to model the opening for my lifts. So I'm going to model 2 lift openings for the 6 meter length shear wall. See how easy it is to model the opening. All I need to specify is the height and breadth of the opening and the location of the opening from the lower left corner of the shear wall. That's it. I can put a fence or select it one by one, and that's it. The opening is created. The same way, I'm going to create the opening on the right side. That's it. We finished modeling the opening. So you see how easy it is to model a shear wall with opening, a completely physical modeling, a wall as a wall, a slab as a slab, a foundation as a foundation. No need to model a wall as a plate element and a slab as a plate element measures, which we generally used to do it in general purpose structure analysis program. Now I'm showing the gravity load modeling, dead load and live loads. So the self weight of all the structural components which we model here will be automatically considered, and on top of that, any superimposed dead load we can model it here. So I use a superimposed dead load of 1 kilonewton per meter square and a live load of 3 kilonewton per meter square. And then the mass dead load is used only for response spectral analysis. For dynamic analysis, I use 2.5. I derived it from 100% of dead load plus 50% of live load. Okay, so I applied the gravity loads to the floors, the roof, as well as the typical floors in my building. That's it. We finished modeling the gravity loads. The other loads available are line load, point load, snow load, etc. So if you have any water tanks in your roof, you can easily model it as point loads. And now we perform the integrity check. The integrity check says no errors in the graphical, in the geometrical modeling. That's it. We have now finished the modeling of the 10-story building in RAM Modeler. Next, let's see how easy it is to apply the lateral load and how to perform a finite element analysis, and also to create a stage construction analysis and modeling. Okay. And the codes which I'm going to use is the Singapore standard, the National Annex to Singapore standard EN 1991-14. This is for the wind load code. Okay. And you can see here the NA 2.4 clause states that the fundamental value of basic wind velocity VB to be adopted for Singapore is 20 meters per second. And this may slightly vary for Malaysia because unlike Singapore, Malaysia is a big region, so it will have a different basic wind speed for different regions. So depending on your project, you need to refer to the National Annex for your Euro code and then find out the basic wind velocity VBO. Okay. And next other code which I'm going to reference is the seismic code, National Annex to Singapore Standard EN 1998 Part 1 2013. And this is for Singapore. Okay, you can see that the clause 3.21 in table NA.1, Singapore values for nationally determined parameters described in SSEN 1998. 1998, this is the seismic code, Euro code, seismic code, okay, Part 1 2013. You see that the AG value, that is the ground acceleration, okay, reference ground acceleration to be exact, in Singapore, this code clause recommends as 0.175 meters per second square. This is very important. Okay, so these two, take a note of these two: wind velocity, which is 20 meters per second, basic wind velocity, and AG, reference ground acceleration, as 0.175 meters per second square. Okay, with that note, let's see how do we model the lateral loads in Ramframe. Okay, so first we set up the criteria. So here you can see I've chosen the Eurocode Singapore National Annex for live load reduction. And next is the Eurocode factors. So here the partial factors for gravity load combinations, partial factors for resistance, live load reduction, and the design yield strength. We can all modify here to suit our National Annex. Okay. And then we move on to Ramframe, where we specify the lateral load. So first we specify the criteria. By default, P delta analysis is considered, and here I chose the default mesh size, and then construction stage analysis. So here I hit on the generate stages to create the stages automatically. The program will generate all the 11 stages for this 10-story building. There is a plinth level on the bottom, that's why it's 11 stages. Okay. And here I specify the concrete material mode. So I'm going to use the CEB code for the creep and shrinkage for the long-term calculations. And here I'm going to assign the stage number for the entire building. And you can see the program automatically assigns the stages, okay, and the concrete properties for CEB FIP properties for the old building. Next is the concrete properties for the diaphragm. Again, I'm going to use the CEB code for the diaphragm. Okay, now let's look at the gravity loads. The program automatically calculates the gravity load from RAM modeler, which we just entered before. Now I'm showing you how to apply a wind load. So choose the wind load code from here. I'm going to use the Euro code EN 1991, part 1, part 4, 2005. And here is the dialog for the wind load specification. All I need to specify is the basic wind speed, basic wind velocity, VB. And as per the code, as I explained, the National Annex for Singapore, as per the clause which I explained, that says that NA is 2.4. The basic wind speed that needs to be adopted for Singapore for the whole country is 20 meters per second. So based on that, I change this default 25 to 20 and press OK. And you see that the wind loads are generated both plus eccentricity and minus eccentricity in both X and Y directions. Totally 6 wind loads have been generated. So next is the seismic load, static seismic load first. Okay, again, I'm choosing the Euro code EN 1998, part 1, 2004. And using the lateral force method, I'm specifying the side properties here as per National Annex. And then the design ground accelerations here is very important. The default value is very high. Okay, I already talked to the developers to modify the default value. So you need to refer to the National Annex of your country. So as per Singapore National Annex, it is 0.175 reference ground acceleration, AG, 0.175 meters per second square. With that, we just press OK, and you can see the 4 wind load seismic load codes, seismic loads are generated automatically. Next is the iGen solution. So I'm using 33 more shapes. That is the default. Just to view the more shapes on the screen, I've added this load case. Next is the response spectra load case. Again, I choose the Euro code EN 1998 response spectra. Specify the direction as X and Y axis, and the design ground acceleration reference AG is 0.175. And then I specify the side properties using the National Annex and spectra values. Ground type C. Okay, Singapore National Annex starts from C. Okay, but this example I just chose EA. That's fine. Okay. And we have finished generating the response spectra load cases, 4 load cases. Next is center of rigidity. We can create a separate load case for center of rigidity so that we can view it graphically. Next is stage construction analysis. And note that there are 2 methods. One is a simple method and another one is a detailed method, advanced method, stage analysis with time-dependent effects like stiffness, creep, and shrinkage. And I'm going to replace the dead load cases with the stage construction analysis results. We finished the analysis. It just takes two minutes. I edited the time so that you don't waste the 2 minutes. And we can see the meshed view of the building. Not just the meshing, but also the stitching happens automatically. And we use a coarse mesh of nearly 1.5 meter. That doesn't take much time for the analysis. For this 10-story building, including stage construction analysis, it took approximately 2 minutes. So here we can see the stage numbers starting from stage 1, 2, 3, 4. Okay, this is how we are going to build the structure. So the stage effect is very important, particularly for high-rise building, and particularly when you have this transfer slabs, this effect will be very, very important. Okay, so here I'm selecting all the load cases for analysis. If we finish the analysis. Okay, so now we just saw the lateral loads such as wind load and seismic load application and how to model the stage construction, which is very simple, and we finished the analysis. Let's see the post-processing capabilities of this program. Now that we finished the analysis, let's see what is the results that we can see. So first thing is a displacement. So program shows you a nice displacement contour. For dead load, we notice it's 8.24 millimeter. For live load is 1.4 millimeter. For wind load, it is 0.36 millimeter, and we can even animate it with a better scale so that we can view it easily with our eyes. So 100 times enlarged, we can see the building deflection due to wind load. That is 0.36 millimeter only. The huge shear walls reduce the lateral deflections. Okay, next we'll see the wind load in other direction, which is close to 1 millimeter, and we see the static seismic load, which is 1.46 millimeter static seismic, and similarly we'll see the dynamic seismic, that is a response spectra, which is 1.1 millimeter. So we have viewed the deflection. We noticed that the lateral loads such as wind load and seismic load doesn't produce high deflections, but we have to verify that with the load combinations. What we've seen is just primary load cases. So now let's see the center of rigidity and center of mass. Okay, I'm switching off the walls, beams, columns so that we see empty screen, and there you see the center of rigidity, center of mass in brown color and the coordinates of it, and then the blue color shows you the center of rigidity. And notice the difference in coordinates, the slight difference between the x and y coordinate. The z coordinate will remain same for both, but the x and z coordinate changes slightly, and that's where the eccentricity, the difference between the center of mass and center of rigidity, eccentricity, that will create the torsion effect due to the lateral load. So the program takes care of this automatically. Okay, now let's see the lateral force, the story forces. Okay, graphically apply story forces. Just for example, a wind load in left to right, x direction. So here you see the wind load. As you can see, the wind load increases as the height increases, but for some floors is reducing. You can see the bottom floors have a better height, a bigger height, 4 meters. So that's why the wind load is slightly more at the bottom one. But after that, you can see constant for certain floors, and then it's again increasing because of the height of the building. Wind load will be more, and the top roof is of lesser area, so the contribution from the roof is lesser. That's why the floor below the roof also getting a lesser wind load. Next, we look at the the story shears. The first one we saw is the apply story forces. Next one, the brown color one is the story shears. The story shear increases as we go down. Okay, you can see the story shear for the roof, and then gradually as we go down, maximum is at the ground floor. So this graphical display of the apply story forces and story shear explains you the verification of the lateral load very easily. Okay, and now we can switch on all the layers of the buildings to see the whole building. Then we can have a look on the reaction also, but I'm more interested on the reactions for the shear walls, how it is going to give the reactions for the shear wall. That's what I'm more interested. So here you can see the support reactions. I'm going to filter it to view it more clearly. I'm switching off all the beams and slabs so that we can see only the columns and walls, and then we can view not just for the columns and beams, but also for the shear wall, the in-between nodes also, for all the nodes, and only for, say, vertical reaction only. Apply it. Okay, and now we can see, I need to choose the load case, okay, and then apply, and now we can see the shear wall, the continuous support reactions are shown. Okay, the meshing, the nodes inside the shear wall, due to meshing, those reactions are also shown up here. Similarly, I can see for other load cases such as wind load, where you can see the compression and tension in the shear wall. Okay, so we have now verified the post-processing results such as deflection diagram and support reactions and story shear and apply story forces, etc., etc. Similarly, we can view bending moment diagram, shear force diagram, etc., which is I'm skipping for time reason. Okay. Next thing I want to show you is the load combinations, how to generate the load combinations. Okay, so just choose the code. In this case, it's Euro code, and then the modify the factors for Singapore National Annex. Okay, and then hit the generate button, and that will generate the load combinations automatically. So in this example, I already created the load combination, which I'm going to delete and show you how to regenerate. Just hit the generate button, and here you can see the hundreds of load combinations as per Eurocode UK National Annex generated. And we can fine tune it for Singapore National Annex as well. Okay. And now we can view the reflection diagram for the load combinations as well. And more shapes. Here you can see the first more shape is about the x-axis on the y-axis, okay, and the second more shape is the other direction, x direction. From this more shape, we can understand the weakest directions of your building. Okay, third more shape is a torsional more shape, twisting. And we can pull out the reports such as center of rigidity, periods, and modes, where you can see the percentage of mass participation and various other reports. Okay, let's see the periods and modes. Okay, that's most important. We have to make sure that all the masses are participating. So here you can see the frequencies and periods, and mass participation factors, and then effective mass factors in terms of percentage. So here you can see the participation of every motion, and finally the cumulative effect, 100% in both the directions, and also the rotation. Okay. So the 33 more shape is good enough to capture all the, in fact, you can see in 31st more shape itself, we achieve 100% for 2 directions. Okay. So 33rd more shape only we achieve 100% in all the 3 directions. Okay, we can also pull out torsional irregularity data like this from the report of RAM structural system drift. And then soft story irregularity data, using which we can easily find out the soft stories. Next, we'll look at the concrete gravity analysis. We just need to perform a concrete gravity analysis to prepare the model ready for concrete design. Okay, due to time, I'm just going to fast forward it, and after we analyze it, we can see the support reactions for every flow. So this is only for gravity. Okay, and we can view the displacement due to gravity load for the slabs also. Next, we'll look at the most important part, the concrete design and detailing estimation in RCDC. Here, using RCDC, which is part of the StatPro license, we can design and detail beams, columns, walls, slabs, footings, pile caps, and staircase, and also detailing, okay, as per both Singapore as well as Malaysia National Annex to EN 1992. We can also produce bill of material, cost estimation, and bar bending schedule. So on the screen, you notice that the green color is shown for modeling. That means we finished the modeling, Ramframe finished the analysis, and Ram Concrete finished the gravity analysis. So now the beam column design can be done in Ram structural system itself. But because I'm going to follow the Singapore National Annex, which is not available in Ram structural system, I'm going to use RCDC to design the concrete elements. All I need to do is just choose the Ram structural system file, which I just finished the analysis, and then choose the design element. In this case, I'm choosing the columns. So you can see that RCDC reads the results of RAM structural system, and now it shows all the columns and walls and shear wall on the right side in plan view. All I need to do is just specify some design settings, such as ductile design is required or not. Since Singapore, we don't need to perform ductile design. If at all required to perform, we follow DCL. Okay. So this is design ductile light. Okay, so in this case, I'm not performing ductile design. Okay, but the program has the facilities to design, and here I specify the reinforcement settings and the design settings. Okay, fast forward a little bit. Okay, and the detailing settings such as the laps, how I'm going to provide the laps, and then the load combinations. I can either import it from RAM structural system. In this case, I imported it, or you can also generate the load combinations directly from here for any code, including Eurocode. And unfactored load combination also we can generate it from here for crack width check. And then perform the concrete column design. Okay, and this spreadsheet shows you the results of the column design, and we can perform the grouping as well and produce this column schedule. And here you can see the column schedule with the grouped columns. Columns having same size and same reinforcement are grouped together. And here you can see the column size, main reinforcement, and the shear links, and also for the walls. So the columns and walls are automatically numbered alphanumerically. And there is a combined wall as well as a lift core, which is having labeled as CW. Okay, so we can save this schedule, column schedule, as a DXF file. And next, let's see what are the other reports that we can pull out. Detailing, okay, the cross-sectional detailing for both the shear wall and the column. This takes few seconds after you click the button, and now the detailing is ready. And here you can see the column detail as a grouped column. It's up to you whether you want to have this detailing for grouped column or ungrouped column, okay, for individual columns. And the separate diagram for links, and the grade of concrete, grade of steel, and the cover details are also mentioned, and the wall detailing as well. And on the right side is a lift core where we have a combined wall. So the detailing for the combined wall also shown up, cross sections as well as separate drawings for the separate details for the links on the right side. So this drawing manually takes a lot of time, but within the software, it just takes few seconds to generate it. And I'm saving this as a DXF file as column and wall details so that later you can open up in any CAD software to put in some sheet and labels and modifications if required. And next is a column elevation detail drawing. I click off another button. We have this column elevation detail drawing. And note that the column laps are not shown here, the reinforcement laps, which will be shown up later once we specify the stock length of the bar. Okay, so I'm saving this as column elevation details. Next, we pull out some report for design summary, column design summary. This is a summarize for the whole building, all the column design for the whole building, column as well as wall design. So it just shows you the levels, the size of the column, wall, material, concrete, steel, grade, and the covering load case, analysis load case, and axial and biaxial moments, and the percentage of steel provided, interaction ratio, main and secondary links. Okay. That's it, just summary. And if you needed detailed calculations, just click another button, and that's it. Just to save time, I selected it for only one column group, and you can see the report. This report will give a detailed calculation, just like manual calculation with codal clauses. Okay, so here you can see the calculation for slenderness check, design moment, bending moment, biaxial bending check, design for shear, design of links, all step-by-step calculations, including the equations. And finally, crack width check. There's a separate report for crack width check as well. Stress limit check as well. I'm going to fast forward because of time. And now finally, bill of quantities. The program can generate 3 different types of bill of quantities. Singapore dollar is implemented. All you need to do is specify the local rates, and the program multiplies the rates with the volume of concrete and the tonnage of a reinforcement and the shuttering area, and gives you a total cost for the whole building. This is not for the whole building. This is only for the columns that we design now. Okay. So 3 different types of bill of quantity. Okay, so within few minutes, you remember how many drawings, how many reports that we generated. Text schedule, detailed drawing, column elevation drawing, design summary, design calculation, crack width check, stress limit check, failure diagnostics, bill of quantity in 3 different formats. The failure diagnostics report will be useful in case if your column fails. Then we can find out what is the reason for failure. In our case, fortunately or unfortunately, no column failed. So this failure diagnostic report is empty. Now we are showing the bar bending schedule. Just one click on the BBS menu on the top. Here I generated the bar bending schedule just for one column because it's a time-consuming job. Here you see the laps, okay, reinforcement laps. And this is useful for the contractor who actually build this on the site. And here's the bar bending schedule, which is useful for the contractor who actually build the structure. So this is also shown up in a spreadsheet view like this. You can just send this spreadsheet to the bar manufacturer like One Steel in Singapore, who can ship this bent bars to your site. That's it. We can see some advanced features such as redesigning the column. First of all, viewing the interaction diagram of the column in 3 dimensions. And then quick section of the column, and then redesign. This is a square column of 750 mm by 750 mm, but we can change the shape of the column like I shape, circular shape, channel shape, L shape, T shape, or a hexagon shape, or a capsule shape, or literally any shape that you want to have. The program will design and reinforce it. Okay, so just for demonstration purpose, I'm canceling it. Okay, so with that completes the column design. Now let's see the other features. Many things I can't show because of time limit. Same way we can design the beams, staircases like this, and slabs, schedules like this. Slabs also can be designed. And now let's come to the final one, the mat foundation design. Okay, so on the screen we see the RAM structural system, which shows green color for Ramframe, Ram concrete, Ram modeler. The concrete elements we design using RCDC. And now finally the mat foundation, we need to launch Ram concept directly from Ram structural system. And on the screen we see I'm selecting the ground floor mat, which is modeled already in Ram structural system. And I click of a button, I'm exporting the support reactions as well as the column and lift core, the geometry directly into Ram concept. So here you can see the slab supporting the lift core and the nearby columns near to the lift core. I included that in the mat foundation. Okay, and I modeled the subgrade modulus of the soil also. The program will generate the springs automatically. And I modify the slab thickness from 1.25 meter to 1 meter. And then I'm going to model some extra thicker slab and the column base. Okay. So that's the location I'm going to model a drop cap. Okay, below the column, just to thicken the slab only at the column location to make it to help in the punching shear check. Now I remesh the mat foundation and view it in 3D so that you can understand how the modeling is in 3D. You can see the soffit is smooth, and the top there's a extra protrusion of the column drop to help in punching shear check. And then I finished modeling the design strips. And the steps I skipped it for time being, okay, for time limitation, because of time limitation. Punching shear check also I used. And that's it. All we need to do is perform the analysis. And the program says okay for all the slabs, the column drops, punching shear, everything. Let's see the punching shear status plan separately. And here you can see the USR. USR means unstressed ratio. Unreinforced stress ratio, sorry, unreinforced stress ratio. The 0.9, that's very effective. Any value more than 1 means the program says that the column fails in punching shear, the slab fails in punching shear, and then it'll proceed with the extra reinforcement to make it pass. Then it'll show RSR, reinforced stress ratio. But in our case, even without providing extra reinforcement, just with the help of column drop, the slab passes in punching shear because of column. Note that the punching shear for walls, the program doesn't do it, so we need to take care of that manually. Okay. And here we can see the stress contours, and we can cut a line on the contours to view the bending moment diagram, and then we can see the reinforcement, top reinforcement, bottom reinforcement on the slab. We can also provide manual reinforcement. Usually what I do is I delete all the program design reinforcement and I provide a uniform reinforcement so that it'll be easier in the site. But for complex situations like this, we may not have a uniform reinforcement that may not be economical. So we may have to go with the program design reinforcement. So here we are seeing the 3D view of the reinforcement and see the extra shear reinforcement for the drop cap, the thickened slab that supports the column. That's it. Finally, the estimation. RAM concept gives you the concrete cost, post-tensioning cost, formwork cost, mild steel cost. And in case if you want to do a post-tensioning, it may not be for mat slab, mat foundation, but for the suspended slabs on the above floors, you may want to compare the results of a reinforced concrete slab and a post-tension slab. So you can use this tool to compare whether you're really saving money. You may save some concrete volume, but the post-tensioning labor cost may be expensive. So this tool will help you to come to the decision whether to go for a post-tensioning or to stay with a reinforced concrete slab. So that's about mat foundation design. Okay, and finally, the last step is the BIM interoperability. Now that we finished our 10-story building, all the concrete elements such as beams, columns. Of course, I can't be able to show everything in detail, but the steps are exactly the same. In RCDC, the same way we perform the column design, the same way we finish the beam design as well, and also the footings also. Mat foundation using RAM concept, and now we export this ISM file from RAM structural system, and then using our BIM program, Open Building Designer, we can import the ISM file from RAM structural system, which we just created. Just simple mapping, because both this program from the same vendor, mapping is simple. And you can see now the complete 3D model is imported into the BIM software. And now you can reference this model with other discipline models such as architectural, mechanical, electrical, and then generate a multi-services drawing as well as clash detection, etc., etc., and also to produce section elevation detail drawing and also quantity estimations for the complete model. Okay. And we can pull out that in Excel spreadsheet as well. Okay, so to summarize, Structural Worksheet is a special bundle license of around 8 products from STAR and RAM brands. And in today's webinar, we saw a detailed presentation on 2.5 products, not all the 8 products, okay, just 2.5 products. So summary, completing a concrete building design projects requires several softwares varying from BIM modeling, structural analysis, design, detailing, power bending schedule, quantity, and cost estimation programs. Bentley Structural Worksheet gives a bundled software license which helps complete the project more efficiently at an affordable software cost. If you're not subscribed already, please subscribe to our Bentley YouTube channel, that is Bentley Structural channel. There we can see several recorded webinars like this. Okay, hundreds of webinars. Okay, and also our Learn server has trainings for on-demand trainings and also live trainings, which are free for our Bentley users who are within the Maintenance Select program with Bentley. Support, we have communities, service request manager, and connect advisor. This works nearly 24 hours a day. So with that, I'll hand out over to Swaroop to proceed with the question and answer session. Just a minute before that, I need to conclude with some concluding polls. Okay, excuse me for that. The second poll. Okay, please help me answer this poll. Now that you have seen the presentation involving RAM structural system, RAM concept, and RCDC, would you like to use this program, this workflow in your future project? I'll give you 10 seconds to answer this. Okay, so I see nearly 50% of you answer this poll. 92% say yes. Okay, so only 51% of you have answered this poll. It'll be good if all of you can participate in this poll so that we can see the reach of this webinar and we can do more frequent such webinars. Okay, so thanks for all of you who participated in this poll. Now I see nearly 56% have voted this. Thank you. So I'll close this poll to proceed with the next poll. Would you be interested in to see similar webinar for steel multi-story building? Just today we have finished the webinar on concrete multi-story building. Similarly, would you be interested in seeing a steel multi-story building? Again, it's a yes or no type of poll, so please choose your choice. I'll give you 10 more seconds for this. It's an easy question, so I see nearly 65% already answered the poll. 100% of you say yes. Okay, thank you for answering this poll. So I'll close this poll and let's open up for question and answer session. So Swaroop, over to you.
Okay, so let me see. Thank you very much, first of all, Madan, for this wonderful presentations. We have some questions. Let me just take out 3 questions quickly. Is Singapore National Annex for Eurocode is fully implemented?
For concrete design, yes, it is fully implemented. We have the Singapore National Annex fully implemented in RCDC, and even the live load reduction code as per Singapore National Annex is fully implemented in RAM structural system. But the gap is in the steel. Okay, RAM structural system, even though it is for steel buildings, the Singapore National Annex for steel is still not implemented. I'm chasing the developers for this, but StatPro already has the steel Singapore National Annex as well as concrete National Annex implemented. Whereas with RAM, it is mostly concrete and then as part. Steel design is still based on the Eurocode and the UK National Annex, not yet for Singapore National Annex. Hope that answers the question. Thank you. Next question, please.
Okay. Can we design all the concrete structures element like foundation, staircase, slab, etc.?
Yeah, everything. Literally everything. Beam, column, slab, foundations like isolated footing, pile cap can be designed in RCDC itself, including the slab. And mat foundation, we have a choice of using RAM concept and Stat Foundation Advanced. Both these programs are part of Structural Worksheet. So if you are using StatPro to design the structure, you can use Stat Foundation Advanced to design any kind of foundations. If you're using RAM Structural System to design the building, you can use RAM Concept for designing the mat foundation and RCDC for other type of foundations. And even retaining wall can be possible to design using RAM elements. But of course, there are some limitations on the codes. Almost all our software supports the Eurocodes and American codes, Indian codes. Okay, but RAM element supports only the American, British, and Australian codes. And the retaining wall module is available only for the American and British, not yet for Euro and Australian and Indian codes yet. Okay, so almost every structural element is covered well, which is common in buildings.
Okay, great.
Okay,
thank you.
Next question.
Yeah, the last questions. Can the building have a combination of steel, concrete, and post-tension slabs, composite slabs in one building?
Composite slabs, yes. RAM structural system has a library of composite floor manufacturers from all over the world. So in one building, certain floors may be composite floors, certain floors may be one-way slabs, concrete slabs, certain floors can be two-way slabs, certain floors can be post-tension slabs, certain floors can be reinforced flat slabs. All in one building, yes, it is possible. And that's where the two-way interoperability between RAM structural system and RAM concept comes into picture. Where RAM concept is a specialized program for flat slab, for post-tension slabs. Okay, I hope that answers the question.
Sure. Yeah, I'm sure. I think
I see there are many questions.
Yeah, Madan, go ahead.
Yeah, there are many more questions posted on the screen. I see some just type Revit. Hope you mean compatible with Revit. Yes, through the ISM, we can import and export through Revit. You need to download an ISM plugin for Revit. Just simply do a Google search for ISM plugin for Revit, and if you are a Bentley user, you can download it for free. And even if you're not a Bentley user, you can still download it for free and install it on Revit. Then you can see a Bentley menu in Revit, using which you can interoperate with all the structural programs of Bentley with Revit. Some of you asked for recording to send to you. Yes, I believe the recording will be sent to you. Kindly send on my registered email address. Yeah, good. Thank you for the compliments. Okay. Next question is, how does RCDC integrate with the project using StatPro analysis? The same way, RCDC, even though it is part of StatPro Advanced, it can be launched as a standalone program. Once you install Structural Worksheet, where StatPro, RAM are all there, when you install StatPro, the RCDC also getting installed, and there's a separate icon for RCDC. And when you launch RCDC, all you need to do is just choose the input file of either a RAM structural system model or a StatPro model or a ETABS model also. Okay, but prior to that, the model has to be analyzed in this one of these three softwares. Okay, just like I show today, how do I import a RAM structural system model? The same way you import a StatPro model and proceed with the column design, beam design. Same way I shown today. Okay, hope that answers your question. Next question is, how pattern live load being considered in tower model? Okay, the pattern loads are considered only in RAM concept in 3D. Okay, as a checkerboard loading. We have 10 patterns that we can create and request the program to analyze for the worst case scenario. And in RAM structural system, the skip loading for one-way flow, we call it a skip loading, alternate span loading for one-way flow. That is automatically considered also. Okay. So both RAM concept and RAM structural system considers this pattern loading. Okay, next question is, RCDC design taken care pattern dead load live loading at the design stage, or it need to be taken care during analysis stage by RAM or STAT? Not at the design stage. It has to be taken care of in the analysis stage itself. In RAM, it is easy because the combination of RAM structural system and RAM concept will help you to do this pattern loading more easier. Whereas instead, we need to do it manually because the pattern loading is not available automatically in StatPro. We have to manually create flow loads for every panels. So that is a little bit time consuming. Okay, hope that answers your question. Another question, RAM able to design precast elements in temporary stage and permanent stage. The program RAM is not specialized for precast elements. But precast is just a type of construction, isn't it? It just helps up speeding up the construction. Finally, when you assemble all the precast elements, it becomes like a cast in situ. It behaves like a cast in situ. Only the joints has to be released according to the number of reinforcement that is going to the other element. We need to play with the member release command. Okay. And RAM elements has even RAM structural system has a feature called tilted tilted walls. Okay, tilted walls are mostly precast and also sometimes cast in situ also. Okay, so RAM structural system and RAM elements has this tilted wall design as well. Okay, one of you asked for, will you provide technical assistance if we face issues while proceeding, I believe, project? Yes, definitely. Yeah. Swaroop can comment on this technical assistance. We have keys with Virtuoso license, which will help you to get assistance from Bentley.
Sure. I think when they subscribe basically for the Virtuoso subscriptions, so it's a bundle actually. So information's is all there in the websites, but anytime feel free to approach me. I'll be able to guide you through. Yeah.
Another question is, RCDC able to design underground circular structures and not as E or SS? I don't know what you mean by E or SS for structural analysis and rebar design directly. No, RCDC is not meant for underground circular structure. RCDC is developed for normal type of building type of structures: beam, column, slab, wall, and foundations. Okay, Circular structures, I hope you mean circular water tank type of structures. No, it is not developed for that. We are working towards that. But rectangular tanks, yes. Rectangular tanks can be on the ground, underground, elevated. We have recently introduced the rectangular water tank design, but only as per Euro code now. Other codes will be implemented later. I believe we have covered almost all the questions, Swarup. I hope we can conclude this presentation today. Thank you.
Okay, all right. Thanks. So yeah, we will definitely look forward for more sessions, but there is some announcement. Also, let me share those informations with our audience. Just a minute. Yeah, so there is an announcement about the Going Digital Awards in Infrastructure, which is known as the Year in Infrastructure Awards, as an exciting and well-regarded global competition that recognizes the digital advancement in infrastructure. Since 2004, the awards program has recognized over 4,000 of the world's most outstanding infrastructure projects. Now it's open to all Bentley software users. It's a unique program that's truly global in scope and comprehensive in all categories for all types of infrastructure projects. So nominating your project provides great recognitions, exciting rewards, and unique opportunities to network and promote your organizations. All finalists will present their projects at the Year in Infrastructure 2021 conference. So nominations are open, and the submission deadline is 21st May. So look at this address yi.bentley.com. You can visit there for more information. So feel free to contact any of us. For the Australia, New Zealand, and the Indonesia side, we have Teresia. For Southeast Asia, you can contact Darius Opilas and myself, Swarup. And for India region, you can contact Priyanka and Rajeshi. Their email address is also given here. And we have conducted a couple of days back about the RAM connections and the STAT Foundation Advanced. There are more structural analysis webinars you can find from this link. And our upcoming one webinar on the 3rd June, that's structural worksuite, complete workflow for steel buildings. Yeah. So feel free to register. And in the meantime, if you have any questions, any queries, and some of you are new really how to go for this Virtuosity subscription, you can contact me anytime. Drop me an email, swarup.mondal@bentley.com. All right. So with that, we conclude our sessions today. Thank you very much. Stay safe and have a nice day. So we'll see you again in the next event. All right. Thank you.
Thank you.